So here we have our last example on your slide. 9a minus 2b equals negative 8, and negative 7a plus 3b equals 12. So if you guessed that you were going to use elimination to solve this, excellent job, that is correct. The problem with this one is 9 doesn't go into 7 evenly, 2 doesn't go into 3. So I told you this in class, you want to use your smaller numbers. So I'm not going to use 9 and 7, I'm actually going to use 2 and 3. And notice that my 2 is negative and my 3 is positive, so I already have that negative positive, which is what I need to cancel out my b's. So I'm going to go right ahead and I'm going to multiply the top by 3 and the bottom by positive 2. Again, because this is negative and this is positive already. And I have to distribute that 3 to each part of that equation and that 2 to each part of the bottom equation. So I'm going to have 27a minus 6b equals negative 24. And on the bottom, I'm going to have negative 14a plus 6b equals 24. Oh, how fun. So notice that my b's now have the same coefficient, so that same number in front of it. I have a negative 6 and a positive 6, which cancels them out. I am left with 13a, and that's going to equal 0, because 24 minus 24 and negative 24 plus 24 is going to get me 0. And whenever you divide anything by 0, it's just 0. So that worked out really nice. No crazy numbers, nothing. So now you can either pick your top or bottom equation, the original, and even if you put it into the new one, it's fine, but you just don't want to work with bigger numbers. Try to keep it simple. I'm going to plug it into the bottom, so I'm going to have negative 7 times 0 plus 3b equals 12. This obviously cancels because it becomes 0, so I'm going to have 3b equals 12. To get the b by itself, I have to divide by 3 on both sides, and I'm going to be left with b is 4. Again, keeping in mind the order of the alphabet, so a comes before b. So when I go to write this as an ordered pair, I'm going to have 0, 4 as my final answer. One solution.